So back to probability then for the last part of 8. So we're going to draw 4 keys, and the fourth one is the first office key. So we're just going to tell a little story. You've not picked an office, not an office, not an office, then you pick the office. So our question is, what's the probability of not picking an office key? So not an office key is these 12 and these 6. So there's 18 that aren't for the offices. So 18 out of 23. So the second one is 17 out of 22 because you haven't got 23 keys anymore. You haven't got 18 that don't work in the office, and so on. You get down to here, there's still 5 office keys, but there's only 20 keys to choose from. You multiply these together, you get this probability. Moving on. Right, all the keys are returned to the box, then 3 keys are drawn at random from the box, one after the other, and it says without replacement. Now, just up here, I've assumed that the keys aren't being replaced each time, but in the marking scheme it says if you assume that they are replaced each time, then you'd be fine. So if you kept this at like 18, 18, 18, you'd be alright. Which is generous, I think. But yeah, right. So down here. So all the keys are returned without replacement. What's the probability that one of them is general classroom, one for the science, and one for the office? So for this one, we're just going to tell a story, and we say, right, what if the first key is for the classroom, then the second one's for the science, and the third one's for the office? And I know it can be done in a different order, but this is the story that we'll tell to start with. So 12 out of 23, 6 out of 22, 5 out of 21. And then we've got to deal with, okay, what about the order? Because we can mess this around. Now, if the order wasn't important to us, it would be an easier question. Sometimes it would be a choose question. But because the order matters, so you can't, just because you pick the classroom door doesn't mean you can put it in a science room or in an office. So the order is important. And we can see, you can write them out, and you can see that there's 6 different ways of doing that. So you're basically going to multiply this probability by 6. Or we can use our boxes, and we can say, right, how many options do we have here? We have 3 options, classroom, science or office. How many options do we now have here? Well, there's only 2 because you've used an option there, and how many options here? So it's 1. So 3, 2 and 1. There are other ways of doing that and getting the 6. Talk to me if you need an alternate way. There's your answer.